So, good evening, everybody. Today we are going to learn a very important function of microcontroller, which is called interrupt. So, interrupt, as the name suggested, you might have understood that interrupt means it is something related to pause or halt, interruption, break, some kind of things like this. You know, conventionally, the people when this you need to halt for some time. Normally, your brain it will come. Okay, we will put one delay. Delay is also an interrupt, but the problem of delay is it will halt the entire program. Entire thing it will pause. It will not go anywhere. But interrupt is it is not halt. When that particular event is occurring, it is going to some service routine and started to execute the work. System is not in halt. Okay. So this example I used to give always. Say now I am taking some class. All you are present in my lab. So I am taking some class. Okay. So suddenly one of the director of my institute entered inside the lab. Then what I will tell? I will tell I'll beg a pardon to you. Okay, please, my director has come. So let me go there. I will talk to him and I will attend his queries. Then I will come to you and I will start to teaching from where I left you. This is the example of an interrupt. And what the queries I was discussing with my director, that is called the interrupt service routine. So the event that my director entered inside the lab, that is called interrupt. And the instruction I was following and I was executing, that is the interrupt service routine. Let us take another example. So when I was teaching you, so immediately one of my director entered. Then naturally I will go to attend him. While I was talking to him, immediately my chairman also entered. Then what I will tell? I will tell my director, please excuse me because chairman has come, so I have to go to resolve his query. So I will go there. I will resolve his query. Then I will come again to my director. I will execute his query, and then again I will come to you the main function, the main assignment, that is to teach you. I will start to execute. The second example is called the priority of interrupt. At a certain time, if more number of such interruption occurred, so which is to be executed first and what way, that is called priority of interrupt. So this way we are going to learn. So in microcontroller, how we will do this, that we will learn today. It is very important for different aspects, but mainly it is very important for high-speed pulse count. Okay, high-speed pulse counting. So when the very high-speed pulses are coming, normal general purpose I/O is not that much faster to read it. That time the interrupt is designed in that way. Okay, so now I will request Yash to share your screen and start your PPT.
Yes, sir. Sir, can you see my screen?
Yeah, I can see. Other people can see.
Yes, sir.
Yes, sir.
इसको हटा दे, ये SS लिखा है उसको हटा दे.
So everybody is able to see my screen?
And one thing I'm telling, in the bottom part is not visible. Something in the screen bottom now it is not able to visible. Do something. Last presentation also I have seen the bottom part is not coming properly.
So shall I present it in this way? Is everybody comfortable?
I think this is better.
Okay. Okay, sir. So today's presentation is going to be on external interrupts using Arduino. So what is exactly an interrupt? It is a mechanism by which modules like input output or memory may interrupt the normal processing of the CPU. So now let us look at the types of the interrupt. Generally there are three types of interrupt: internal interrupt, software interrupt, and external interrupt. So for this presentation we are only going to discuss about the external interrupt. What is an external interrupt? An external interrupt is a computer system interrupt that happens as a result of outside interference, whether that's from the user, from peripherals, from other hardware devices, or through a network. So in this, we are only going to discuss two external interrupts here, that is INT0 and INT1. So if you look at the Atmega 328P pin configuration, you can see that the pin number 5 is corresponding to the external interrupt INT1, and the pin number 4 is corresponding to the external interrupt INT0. Now, apart from these two external interrupts, there are also other external interrupts like PCINT13, PCINT12. But we are only considering the INT0 and the INT1 external interrupts because they have independent interrupt controls. And what do you exactly mean by independent interrupt controls? It means that they have their own vector controls. So why are these interrupts required? They are required to improve the processing efficiency of the central processing unit. External interruptions are good for dealing quickly with external world events, such as new data on serial port, a sensor being activated or deactivated, voltage change on your ADC, and so on and so forth. So take it like most external devices are slower than the CPU. So if no interrupt is present, then the CPU would waste a lot of time waiting for the external devices to match with the CPU speed. So this would lead to wastage of CPU time as well as the instruction cycle. So let us now move forward and let us look at the reference table. So let us look at our first register here, that is EICRA, stands for External Interrupt Control Register A. Now as the name suggests, it is the external interrupt control. So it means that it controls the external interrupts. So you can see over here that the last 4 bits 0, 1, 2 and 3 are responsible for controlling the INT0 and the INT1, out of which the 0th and the first bit is responsible for controlling the INT0, and the second and third bit is responsible for controlling the external interrupt INT1. Now ISC11, that these two are the second and the third pins which are responsible for controlling the INT1. Now let us go through one by one. 00 corresponds to the low level of INT1 that generates an interrupt request. 01 is any logical change on the INT1 generates an interrupt request. 10 corresponds to the falling edge of INT1 that generates an interrupt request, and 11 is the rising edge of the INT1 that generates an interrupt request. Now what is this falling edge and what is this rising edge? So look at this. So whenever my pulse goes from low to high, so the count will occur here. That is, that this will experience, like look at the code here. I've initialized my X to 0. Okay. And the external initialization function is also being called here. which is this external initialization function, which is initialized over. Now I will come to this later, but look at this. This ISR stands for the interrupt service routine, and this int0 underscore vect stands for int0 interrupt in vector form. So when my x is initialized to 0, and when the rising edge occurs, that means when my pulse goes from low to high, this x value will be incremented whenever the ISR is invoked. Okay, so now let us look at the registers. One corresponds to the rising edge of the INT1. Now over here in this code we are using the INT0 pin configuration. The everything remains the same, just we are only controlling the 0th and the ith bit. Okay, so let us now look at the code over here. You can see that EICRA, the last 2 bit is set to 1. Okay, just as I said, the last 2 bit is set to 1. The last 2 bit is set to 1. That is, the rising edge of INT0 generates an interrupt request. So whenever it is set from low to high, it will set an interrupt request. Now let us look at EIMSK, that is the external interrupt mask register. The last 2 bit, you can see the 0th bit is responsible for enabling the INT0 external interrupt, and the first bit is responsible for enabling the INT1 and external interrupt. So this register along with the status register enables the external interrupt INT1 and INT0. Okay, but don't confuse this with the EICRA register, because this register is used for controlling the INT1 and INT0 register. That out of these 4 options, which options are you going to choose? But this one is for enabling the INT1 and INT0 register. Okay, now let us look at this code. SREG, that is the ith bit or the 7th bit, is set to high. That means it has set the global interrupt to 1. Okay, and this SCI over here is the global interrupt enabler that will globalize all the interrupts. And EIMSK, as you can see, the last bit is set to 1. So since we are using the INT0 external register, external interrupt, so we have set the EIMSK last bit, that is the 0th bit, to 1. Okay, and finally we are having the circuit diagram over here. So you can see that the second pin corresponds to the INT0 external interrupt, and the third pin corresponds to the INT1 external interrupt. So the second pin is actually connected to this switch which is present over here, and I have also connected pin 0 to the virtual terminal, pin 0 and pin 1, and this end of the switch is connected to the DC pulse, and this is connected to the ground. Okay, so the scenario is quite simple, that when I'm going to tap the switch, the pulse is going to go from low to high, a rising edge will be experienced, and the counter is going to increment its count as long as you are tapping the switch. If you are tapping the switch and you hold it and then you release it, then no counting will be experienced. But as long as you are tapping it continuously, then only the increment will occur. Okay, so I would request, before that, if anybody has any questions, then please they can ask.
Do we require the SCI function here?
Huh?
Do we require the SCI function here that you have called SCI? The code may run even without that.
Yeah,
it's
yeah,
no
you can use it without that.
Yeah, because that is your SREG. You are setting the ith bit. That same thing. It's a macro. It is no need also.
SCI is not required.
I have a question with regard to the code. Could we just go to the code once?
Okay.
Slide 9. Yeah.
Respond.
So over here inside the infinite while loop, you've written serial print ln x. So that will be printing, that will be running infinitely and constantly printing the value of x into the serial ports. What is the use of that?
You see, this ISR is actually the interrupt service routine, and it is corresponding to the external interrupt int0. So whenever you are tapping the switch, the pulse is going to go from low to high. So that then and there it's going to increment the value. Okay, from x to x plus plus. So in the infinite while loop, what we are putting this command in the infinite while loop so that we can, because the baud rate is 9600 and it is going very fast. So whenever the value is going to come once, so it's going to suddenly appear and then disappear. So we want that continuous so that we can actually visualize that what is actually the value. That is why we are putting it under infinite while loop.
So let us run the code, then we will understand what difference will happen. We will put that serial print in the interrupt also. Then we will see what will happen. What
Yeah.
are the things happening? Now,
So
Sharif has asked one question that what mean by globalizing the interrupt? You can answer.
yeah, so globalizing the interrupt means that if you globalize the interrupt, so you can enable, like as I told you, SREG, you see, this register, that is SREG register, enables the external interrupt and INT1 and INT0. So SREG register, that is this global register, is also responsible for enabling the external interrupts, that is INT0 and INT1. It can't rely solely on EIMSK. It has to be globally, it has to be initialized by the SREG register.
So basically, any kind of interrupt, when you are going to use that ith bit, I bit of the status register to be set high. That is the thing. Without that, no interrupt will occur, and no interrupt will enable. So this is
Yes,
the
sir.
globally. All the interrupt, any interrupt, if you want to use, so that I bit of the status register should be enabled. That's all.
Anybody, any questions? Any further? Okay. So I would request Anish to present his demo in Proteus by running the code and the simulation.
Yes, you can stop sharing so that I can share my screen.
Yeah. Is it okay?
Everyone can see my screen.
Yeah.
Alright, so this is the same code that he had shown you in the PPT. So I just skim through the code once. Here we have set an integer x is 0. Basically, whenever the pulse will be set to high through the input pin 0, the ISR will get accessed and the value of x will increase. So whenever I click the push button, the value will increase from 1 to from 0 to 1, then 2, then 3. Basically, it will count the number of pulses there are. Okay. So now I'll run the code in Proteus. So this is the same circuit, just I have kept all the components on one side. Right, is the circuit visible to everyone?
और थोड़ा बड़ा करो.
Yeah.
Right,
Yes.
is it visible now? Okay. So like our plan was to push and pull the switch, this push button, and show that whenever we push the button, the value will increase. But there seems to be some issue with the version of Proteus, because of which the push button, once pushed, it is working. All right. So instead of pushing and pulling, I have kept a pulse as the input voltage. All right. So I've kept a pulse as an input voltage. I'll also show you by changing it to a DC voltage. All right. For now, look for a pulse. All right. This is a pulse which goes high and low at an interval of 1 second. All right. So I'll run the code. I'll upload the code here. All right. So you see here the value of the virtual terminal. If I zoom in here, see 4, 5, it is changing again and again. Can you all see? I'll pause the simulation for once. See, it is 6 now. It has been changing from 0, 1, 2, 3, 4, 5, 6. All right. Now if I play the simulation, again it will 7, 8. It will keep on increasing. All right. So this is for a pulse. All right. Every second one pulse is coming. It is going high and low, and for every pulse, the value is incrementing. Now I'll show what if I give a constant.
One small modification in that pulse, you can connect to an oscilloscope also.
In that pulse. All right, sir. I'll do it, sir. All right, sir. I'll include one oscilloscope. Alright, so here I have connected the oscilloscope. I'll run the simulation. The oscilloscope is open. See the pulse, the yellow line. This is the oscilloscope of the pulse, and this is the virtual terminal, which increase with increasing values. All right, 10. Now it will change to 11. Open Proteus again. 1 second. Just crashed.
Just you can increase the frequency also and so that it is counting fast.
Yes, sir. I'll increase the frequency and do so. Yes, sir. Already have connected the oscilloscope. Alright, now I'll change the frequency. I'll stop the simulation and change the frequency. Alright, this is pulse. You see the pulse frequency is 1 Hertz. I'll increase the frequency to 10 Hertz. Alright. See the values are changing so fast. And the pulses are also even faster now. See the values have went to 36, 37 in a matter of seconds. Alright, now I'll show you what if we give a constant DC source. Alright, so I'll change the pulse. Stop the simulation first. Delete this wire. Alright, I'll give it a constant DC source of 5 volt. Okay. Now I'll run the simulation. Wait a second. Debug. It's a constant DC source. So the value will increase once. Alright, now the value won't increase because there is a problem with the switch. Even if I open the push button, it is taking the value of the DC source. There is a problem with the push button in this Proteus. So that's the problem. Otherwise, when a constant DC volt is going, see there is no increment. Alright. So the increment is only there when there is a rising edge. Like when there is a pulse. If anyone has a doubt, please ask.
Could you just show a simulation like sir had said, instead of putting that serial.println x function within the
Yes,
infinite.
yes, I can. Let me upload the code once already. See, in the interrupt, the values are coming 1, 2, 3, 4, 5, 6,
See,
7.
in earlier case, it was that 4, 2, 3 times it was printing. Now it is only one time printing. That is the difference.
Sir, isn't this a much better approach?
No, that is okay, but this our this things is not to print that. It is some when we will be learning the quadrature pulse counting, we will understand that.
Achha,
So
achha.
next is we will learn how to what is a shaft incremental encoder and how to measure the RPM. So that we will learn. So that time we will understand. It is simple thing.
Already.
As you wish. It is not an.
Does anyone have a doubt with the terms like what is called an like increasing edge or like rising edge? If you have any doubts, please ask. No one has any doubts? So তাহলে প্রোটিয়াসটা
Okay,
করতে
I have one. I have one
already.
doubt.
Yes.
Suppose here while you use the pulse source also, so the value was going from 0 to 5 volt. Suppose, okay, in every cycle it was going from 0 to 5. That
Yes.
is an increasing edge. I got that. But if we use suppose 0 to 5, there is an increment. Will there also be an increment when the value goes from say 5 volts to 9 volts or something like that?
We can try that. We can
Okay.
try that and see. I'm not sure.
No, actually that is depend on the pin. So at what logic it is this Proteus is problem.
Yes, sir. It's closing again and again. Actually, my switch is not working. Otherwise, I could have shown you by an increasing voltage if it works or not. But the problem with the switch is once it is taking a pulse, it is not changing it. Like even if I give a pulse and open the switch, still it is
Yes,
taking
yes.
it. I can show you.
Yeah.
There's a
It's
problem
stuck at
with-
5 volts.
I'll show you the problem with the switch. Alright, see, the values are increasing. Alright, I'll open the switch. Alright, see, I have opened the switch.
Yes, but
Still the values are increasing. See, so once a
yes,
pulse
there's
is
some
going, it's
problem.
going with the switch. Otherwise, I could have shown you like in the potentiometer, I would have changed the values of the voltage and increased it and
Alright.
shown what you are asking.
Yes, alright. Sir, what
So,
were you just saying about that pin configure? What? Sir, when I asked the question, you were saying something. I didn't get it.
so will this also work for a sawtooth voltage?
Circuit voltage as in
Sawtooth.
sawtooth. Yes, it should work for a sawtooth voltage too.
No, I mean, what will happen if the voltage is constantly increasing instead of a sharp edge increase?
Exactly. Basically, yeah.
Yes, I understood what you're saying. That is what Rohit told. But the problem is that I cannot show that because the switch is not working properly.
No. ওটা না like মানে what
Not
Rohit
about the
asked
switch,
was
you
ওটাই
keep
শর্ট
the
করছে।
switch
That
from
is what
inside.
Sir said actually.
আরে না
যে
মানে
মানে
আমি
it depends on the
but
pin.
triangulated wave হিসেবে যদি এগোয় একটা
হ্যাঁ
sawtooth
আমি বুঝলাম। আরে তুই বলছিস তো 2 ভোল্ট 3 ভোল্ট 4 ভোল্ট এক এক করে আমি এগোচ্ছি, তো এটা একটা স্ট্রেট লাইনের মতন তৈরি হচ্ছে 45 ডিগ্রি অ্যাঙ্গেলের মতন ভাব। তো সেটায়
হ্যাঁ।
ইনক্রিজ হলে তো হবে কি না সেটাই তো, কিন্তু
হ্যাঁ।
আমি বলছি আমি যদি পোটেনশিওমিটার লাগিয়ে সেটা ইনক্রিজ করছি না, তো let me remove the switch and see what happens. All right, let me remove the switch for
No,
one.
just instead of the pulse
Shayantan,
source,
what were you saying about the pin?
Shika, I don't know completely, but it probably depends on an instantaneous change in voltage. মানে you have to create a rising edge, মানে যেরকম basically তোর flip flop গুলো কাজ করে, that is
না
how
তো
it
এটা যখন একটা এজ নিয়ে
আচ্ছা,
নিচ্ছে
আচ্ছা।
তো না তো এটাতে যখন একটা স্কোয়ার ভোল্টেজ নিচ্ছে ওটা দুটো এজ আছে রাইট, বাট ওটা কাজ করছে অনলি অন ওয়ান এজ, রাইজিং এজ নিয়ে কাজ করছে। সো হোয়াট ইফ আই হ্যাভ জাস্ট ওয়ান এজ, একটা ট্রায়াঙ্গেল ওয়েভ নিলাম, ইট হ্যাজ ওয়ান এজ দ্যাট সার্ভস দ্য পারপাস।
ঠিক আছে এখন
Yes, but the edge is not rising,
You
right? It
choose
just
the
has
edge,
one
right?
falling edge.
আচ্ছা let me see one.
yes, exactly.
একটা ডিসি
This is
ভোল্ট
what I
দিয়ে
was
আমি
like,
পোটেনশিওমিটার
you
রাইজ
can change the source.
yes আমি
Change the
চেঞ্জ
source
করে
and track.
আমি ডিসি সোর্স লাগিয়েছি, আমি এবার পোটেনশিওমিটার দিয়ে ইনক্রিজ করব। হ্যাঁ
No, like you are using the pulse source, you can use instead of using a DC source, you can just use a sinusoid or something.
না সাইনোসয়েডালে হবে না, এজ লাগবে তো,
No, like
সাইনোসয়েডালে
I
এজ
mean,
নেই।
no, no. I'm বলছি, isn't there a built-in sawtooth waveform
আই ডাউট ইট, আই হাইলি ডাউট। একবার দেখ।
like in P-Spice?
দেখছি দাঁড়া।
No, no,
Pulse.
it will not work actually. If
So
you are
that's-
slowly increasing, it will not work because the pin is not made for that kind of. It will
Oh.
only, that interrupt will only occur when in case of the sharp raising.
Okay,
Okay,
Infinite.
sir. Understood.
Understood.
So if you want to measure that one, you should use the ADC.
Okay.
ওকে
No, in case of sine wave, it's not working. See, I've put a sine wave here.
সাইন ওয়েভ ইট ওয়ন্ট ওয়ার্ক বিকজ দেয়ার ইজ নো এজ।
See that it is designed that your for a particular point, if the dy by dt, that value, if that is infinite, theoretically,
Okay. Yes,
then
sir.
only that pin will respond. Otherwise, if it is something is value rather than that, if it is lower than the infinity, this will not work actually.
Okay, sir.
So
But-
this is the purpose of interrupt. External hardware interrupt is for that purpose only. But if you want to measure the sawtooth wave, if you want to do that, you can do it very well using ADC, because it's a slow, it's a continuous changes can be caught. This is the way.
Oh, let's see, Rahul. I've put a single edge. It's not working. I've put a single edge source. All right. Look here. This is single edge source. It's not working.
না আই ওয়াজন্ট সিঙ্গেল এজ ইট ওয়ন্ট ওয়ার্ক না ওরকম না। হ্যাঁ সিঙ্গেল এজ ইট ওয়ন্ট ওয়ার্ক।
I think it needs to be periodic.
Like it needs to go low and high together. Low হবে তারপর high হবে তাহলে চেঞ্জ হবে।
আর ইনস্ট্যান্টেনিয়াসলি হবে সেটা।
হ্যাঁ মানে সেই ইনস্ট্যান্ট তো আমি এক্সটার্নালি কন্ট্রোল করতে পারি।
না স্যার যেটা বললো এই ট্রায়াঙ্গেল বা সটুথ ওটা মানে কনস্ট্যান্ট রাইজ হবে না, সেটা একবারে বাড়বে একবারে কমবে।
আচ্ছা মানে স্লোপটা ইনফিনিটি হতে হবে।
হ্যাঁ
Yes, slope must
Speak
be.
in English, because so many people are from different state, they cannot understand.
Yes, but
Yes, sir,
don't
yes,
use
sir.
Bengali.
All right, all right.
So
Sir, can I stop sharing?
okay, so any other question? Any more question? Anybody?
No, sir.
Okay. So thank you so much. So next I will show you. So next, in the next session, we'll see it for how to count the RPM of a rotating shaft or machine. Okay. So using that time, these things will be required. So that time we will understand what is the work of that.
So when will be the next session?
That I will tell you. In the group, all the group I will circulate. Maybe tomorrow or day after tomorrow sometime.
All right, sir.
So once again, thank you everybody. Thanks for joining. Take care. Bye.
Thank you, sir. Thank you, sir.
Thank you.